Hello ninjas! Welcome back to Math Dojo, where we sharpen our math skills like true warriors. So today, we are going to focus on an important concept and measurement, which is speed. So ready your minds because today's lesson is all about how fast something moves. Let's get started. So, speed is simply the distance traveled per unit of time. In other words, it tells us how fast something is moving. Imagine you are running. Speed will measure how much distance you will cover in a given time. So, if you run farther in a shorter time, that means you're faster. So, to make it easier to remember, we use this speed triangle. Just cover the value you need to find and the formula will appear. To find speed, we will cover the speed. So speed is equals to distance over time. And to find distance, use distance. Speed times time. So lastly, to find time, use time is equals to distance over speed. Let's put this into action with some real problems. So for example, a car travels 240 km to Pampanga in 4 hours. So, ano speed nito? So, 240 km over 4 hours is equals to 60 km per hour. The speed of the car is 60 km per hour. Don't forget the unit because it's important. For the example of 2, another speed problem, a cyclist covers 150 km in 5 hours. So, what is speed? 150 km over 5 hours is equals to 30 km per hour. That means the cyclist is moving at 30 km per hour. Again, always include the unit. So, now that we understand speed, what if we need to find the distance instead? For example, if we know how fast something moves and how long it travels, can we figure out how far it goes? So that's exactly what we will learn next. Another Math Dojo master will guide you through the next part of our lesson, calculating distance. So stay focused ninjas and let's continue.
In continuation to the previous topic, let's move on to distance. Distance is the measure of how far apart two things are. It could be between two objects, points, or places. Distance can be measured in various units, like meters, kilometers, centimeters, miles, and many more, depending on what is being discussed. The formula used in distance is equal to speed times time. Now, let me give you an example. How far can you run away from your friend if you can run at 3 meters per second and you ran for 15 seconds straight? The solution will be 3 times 15, which leads to the answer of 45. Okay, now your turn. A green train moving at the speed of 8 kilometers per hour for 5 hours. How far does it travel? Let me repeat the question. A green train moving at the speed of 80 kilometers per hour for 5 hours. How far does it travel? That is correct. The answer is 400 kilometers.
Now, pag-uusapan naman natin ang time. Ito ay konektado rin sa distance and speed na pinag-usapan natin sa ating lesson. So, before everything else, what is time? Time is the measured period during which an action, process, or condition exists or continues. It tells us the duration of an event or how long does the event has taken place. Mahalaga ito sa pang-araw-araw na buhay dahil nagagamit natin ito sa iba't ibang mga bagay tulad ng paggawa ng mga schedule, pagsukat ng oras ng tamang pagising, at marami pang iba. Time has different units of measurements. It can be by hour, minutes, and seconds. To solve for time, we just have to divide distance by the speed. Kaya nga we have said earlier that time is connected to distance and speed. So just remember the formula T equals D over S, wherein D represents the distance, S for speed, and of course, T for time. Now let's try answering these problems. Here is problem number 1. Let's read. Jude is running at a speed of 8 kilometers per hour. How long will it take him to cover 24 kilometers? As we have said earlier, the formula is time equals distance over speed. We just have to divide distance by the speed. So let's try to analyze the problem. What is the given distance? Correct, it's 24 kilometers. What is the given speed? Correct, it's 8 kilometers per hour. So we have to divide 24 by 8. 24 divided by 8 is? Correct, it's 3. Now, what is the given unit? Correct, it's R. We have to cross out kilometers because kilometer divided by kilometer is 1. That means our final answer is 3 hours. It takes him 3 hours to cover a distance of 24 kilometers with a speed of 8 kilometers per hour. Remember that don't forget to always include the units in your final answer. So let's try to solve another problem. Let's read. A train traveled 54 kilometers at an average speed of 9 kilometers per hour. How long did the journey take? So as we have said, the formula for time is time equals distance divided by the speed. So let's try to analyze again the problem. What is the given distance? Correct, it's 54 kilometers. What is the given speed? Correct, it's 9 kilometers per hour. So we have to divide 54 by 9. 54 divided by 9 is? Correct, it's 6. So what is the given unit? Correct, it's hour. We have to cross out again kilometer because kilometer divided by kilometer is 1. That means our final answer is 6 hours. It takes 6 hours for the train to travel a distance of 54 kilometers at an average speed of 9 kilometers per hour. Again, remember to always include units in your final answer. Now, I want you to also solve the flash problem on board. Let's read. How long does it take for a dog to travel 21 kilometers with a speed of 7 kilometers per hour? You have 10 seconds to answer. So, what is your final answer? Awesome, you are correct. It's 3 hours. Given the formula time equals distance over speed. The distance of 21 kilometers is divided by the speed of 7 kilometers per hour. That means it's 3 hours. Very good, class. I believe you understand the lesson very well. That means you are now ready to enter into another mission of learning. That is all for time. Thank you for your time and see you in your future missions.
Have you ever wrapped a gift or covered your school books with a plastic cover? If you have, then you're actually dealing with area. Area is the amount of space something covers. Area tells us how much flat space is inside a shape. We measure area in square units, such as square centimeters, inches, meters, or even feet. You may be asking, why do we use square units? Well, we use square units because they're the easiest way to completely fill out a shape and measure how much space it covers. Think of it like a sheet of a grid paper, with all those little squares on it. Each tiny square represents 1 square unit. So, if a shape covers 12 squares, the area is 12 units. But what if your shape is way too big to count each square? Well, that's where formulas for the area come in. Instead of counting every single square, we can multiply the number of rows by the number of columns, or simply length times width. This is to help us figure out the area quickly and easily. A plane figure is a flat, two-dimensional shape. That means it only has length and width. Each plane figure has its own special formula. Let's go through them one by one. Here are the formulas to find the area of the following shapes. For rectangle, it is length times width. For square, it is its side squared. For a triangle, it is 1/2 times base times height. For a parallelogram, it is base times height. For a rhombus, it is 1/2 times the length of its first diagonal times the length of its second diagonal. For a trapezoid, it is 1/2 times height times the sum of base 1 plus base 2. And lastly, for a circle, it is pi times radius squared. Once you know the shape, just plug in the numbers and solve. No need to count all those tiny squares. Now that we understand what area is and the formulas for different shapes, let's try finding the area of some plane figures together. First, we'll solve some simple problems. Then, we'll try real-world situations just like you'd find in everyday life. Let's warm up by finding the area of some shapes using the formulas we just learned. Are you ready? Okay, for the first problem. What is the area of a rectangle with a length of 8 centimeters and a width of 5 centimeters? Correct. The answer is 40 square centimeters. That was a direct application of what we learned. Congratulations. Let's try a few more. A triangle with a base of 6 meters and height of 4 meters. What is its area? Yes, you got it again. It's 12 square meters. Now, let's put your skills to the test with some real-life word problems. Mika is decorating the top of her study desk with some colorful paper. The desk is 43 inches long and 29 inches wide. How much paper does she need to cover the whole surface? You can pause the video so you can answer on your own. That's right. Mika will need a colorful paper that covers 1,247 square inches. In this lesson, you didn't just learn how to calculate area, but you also learned what it means. You saw how square units help us measure space, how formulas make it easier, and how these skills apply to real-life situations. You've just taken a big step in mastering measurement. Keep it up. Let's dig deeper and proceed to another topic.
What's up, ninjas? We'll now talk about solid figures, which are shapes that take up space in 3 dimensions. These shapes are not flat, like the ones you are used to draw, but have length, width, and height. Imagine wrapping gift. Surface area is the total amount of wrapping paper you'd need to cover a solid shape. Pretty cool, right? Surface area is the total area of all the outer sides or faces of a solid shape. The first example is the cube. A cube is like a dice, 6 square faces, all the same size. To find the surface area, we use the formula 6 times s squared, where s is the length of one side. For example, if each side of a cube is 5 feet, to get the surface area, we have to get the product of 5 squared, then multiply it by 6. Then we get 150 feet. Let's now talk rectangular prism. A rectangular prism is like a box with opposite faces being the same size. The formula for the surface area is 2 times LW plus LH plus WH, where L is the length, W is the width, and H is the side. For example, let's say we have a box that is 10 centimeters long, 4 centimeters wide, and 6 centimeters high. To get the surface area, we have to multiply 10 times 4, and 4 times 6, and 4 times 6. Now we have 40 plus 60 plus 24. Then we multiply it to 2, we get 248 square centimeters. The next is the cylinder. A cylinder has 2 circular ends and a smooth curved side, like a water bottle. To find the surface area, we use the formula 2 pi r squared plus 2 pi rh, where r is the radius of the circular base and h is the height. For example, if the radius of a cylinder is 4 centimeters and the height is 10 centimeters, to compute the surface area, we have to get the product of 4 squared and 4 times 10. Next, we have to multiply 2 and 16 and 2 and 40. Now we have to add 32 and 80. Now if you going to multiply it to pi, we get 351.68 square centimeters. The next is the cone. A cone has a circular base and a pointy top. For example of this is the ice cream cone. The formula for the surface area is pi r squared plus pi rs, where r is the radius of the base and s is the slant height. For example, if a cone has a radius of 3 centimeters and a slant height of 5 centimeters, to compute the surface area, we have to get the product of 3 squared and 3 times 5. Next, if we add 9 plus 15, we get 24 pi. And if you multiply it to pi, we get 75.4 square centimeters. Let's move on to pyramid. A pyramid has one square base and four rectangular sides that meet a point at the top, like the Egyptian pyramids. To find the surface of the area of the square pyramid, we use the formula b squared plus 2bs, where b is the length of one side of the square base and s is the slant height. For example, if a pyramid has a base of 6 meters and a slant height of 5 meters, to compute the surface area, we have to get the product of 6 squared and 6 times 5. Now we add 36 plus 60, we get 96 square meters. The last one is the sphere. A sphere is a perfectly round object, like a basketball. It has no edges or flat sides. The formula for surface area is simply 4 pi r squared, where r is the radius. Example, if the radius of a basketball is 7 inches, to get the surface area, we have to get the product of 7 squared. Now, we have to multiply 4 times 49 to get 196 pi. Now, if we multiply 196 to pi, we get 615.44 square inches.
Volume is the amount of space inside a three-dimensional object. So for example, kapag pinuno natin ng tubig yung bottle, the water shows us how much space is inside the bottle. It is different from area, since area measures only the surface, pero volume measures the space inside. So to measure the volume, we use cubic units such as cubic centimeters, cubic meters. This is because the volume comes from multiplying three dimensions, which are length, width, and height. So there are few important formulas we must remember. First, for a rectangular prism, we have volume is equal to length times width times height. For a cube, we have volume is equal to side cube since all the sides are equal. And for a cylinder, we have volume is equal to pi times radius squared times height. Here, pi is approximately 3.14. Now let's look at an example for a rectangular prism. If we have a box with a length of 5 cm with a width of 3 cm and height of 2 cm, then volume is equal to 5 times 3 times 2 is equals to 30 cubic centimeters. This means that the box can hold 30 cubic centimeters of space. Another example is that imagine a shoebox with a length of 6 centimeters, a width of 4 centimeters, and a height of 3 centimeters. This means the shoebox can hold 72 cubic centimeters of space. So now for a cylinder. Suppose we have a cylinder with a radius of 3 cm and a height of 10 cm. We calculate it as volume is equal to 3.14 times 3 squared times 10, which gives us about 282.6 cubic centimeters. Another example. A soda can with a radius of 5 cm and height of 12 cm. So the total volume of the can is 942 cubic centimeters. So now let's try an example for a cube. A cube has equal sides, so its volume formula is equal to side cube or side times side times side. So for example, if a cube has a side length of 4 cm, we calculate the volume like this. Volume is equal to 4 times 4 times 4, which gives us 64 cubic centimeters. That means the cube can hold 64 cubic centimeters. Another example for cube. A small dice with equal sides measuring 2 centimeters. So using the formula, it has a total volume of 8 cubic centimeters. So volume isn't just a math concept, it is used every day. For example, when filling a swimming pool, cooking with a measured ingredients, or checking the capacity of gas tank. So now you know what the volume is, how to measure it, and how to calculate it. So I guess that wraps up our topic about volume. So the next topic will be discussed right away.
Okay, so now let's move on to our last topic under measurement. So guys, did you already try to read your electricity or water consumption at home? If not, then this topic will help us to read, understand, and interpret our electric and water meter. So our topic is all about meter reading. So in this topic, we will discuss or we will tackle two subtopics. The first one is the electric reading and the second one is the water reading. For electric reading, we will use the unit kilowatt hour or kWh. And for the water reading, we will use the unit cubic meters or m raised to the third power. Now, let's formally start this discussion by knowing how to read and interpret electric meter. The first thing you want to know is that electric meter is composed of 5 dials. The first dial being labeled as dial letter A, second dial as B, and so on. So, the first dial turns clockwise. The second dial turns counterclockwise. The third one turns clockwise. Fourth, counterclockwise. And lastly, the fifth dial turns clockwise again. So, basically, all odd number dials turn clockwise and all even number dials turn counterclockwise. Now, moving on to the step of reading electric meters. So first things first, you start reading the numbers pointed to by the arrows from right to left, which means that we will start to read dial letter E or the fifth dial to the first dial. So the second one is that when the pointer is between two numbers, for example 2 and 3, write down the smaller number. So if the pointer is between the numbers 2 and 3, what will we choose? Of course, the lower number, which is the number 2. But there is an exemption in this rule. So when the pointer is between 0 and 9, we will choose number 9. Okay, take note of that. And the last step is that if the pointer appears to be exactly on the number or on a number, check the dial to the right to find out the correct reading. So for example, we are reading dial number 4 or dial letter D. We need to check dial letter E or dial number 5 because it is on the right side of dial number 4 or dial letter D. So if the dial on the right has passed 0, then use the number the pointer is pointing to on the dial you are reading. For example, the pointer points on number 5. Then the right dial is number 1. So we will take 5. Now, if the dial has not passed 0, then make use of the smaller number on the dial you are reading. So I hope that is right. Now, let's try here an example. Dial A to dial E. So, we need to first look at dial E. So, it is 5. So, 5. Dial D shows the point is between two numbers, which are 8 and 9. We will take, yes, number 8. So, in dial letter C, we will take, yes, number 5. For B, we will take 0. And for A, we will take 2 because the point is directly pointing to 2. And the right dial, which is the B, pass the number 0. Now, so here this reads, we will read from dial A to dial E. So this reads 20,585 kilowatt.
hour. Kilowatts hour. Now, let's try solving a example problem. So the formula for finding the consumption is that current reading minus previous reading. Now, here is our example problem. A store consumed 125 kilowatt hour last month. The owner of the store wants to compute the monthly electrical consumption, so he checked the digital electric meter, which shows that the current reading is 199 kilowatt hour. How many kilowatt hour did the store consume this month? So here we have, let's identify the current reading and the previous reading first. Here is the previous reading is 125 kilowatt hour, which marks by the word last month. And for the current reading, we have the 199 kilowatt hour, which marks by the words current reading. Now, here is the solution. Consumption equals current reading minus previous reading. So our current reading is 199 kilowatt hour minus our previous reading, which is 125 kilowatt hour. That gives us the final answer, 74 kilowatt hour. Now for our water reading, this will be discussed by Teacher Aliana.
Now let's move on in water consumption reading. Water meter measures the amount of water used, which is measured in cubic meter. There are two types of water meter, the analog and digital meter. First, let's talk about the analog meter. In analog meters, the water meter has only 4 dials, which move clockwise, just like this illustration. Now let's try the illustrations to understand the steps of reading a water meter. We have 4 dials which are A, B, C, and D. The rules are almost similar to reading the electric meter. Step 1. When reading a water meter, we start from right to left. So we'll start from dial D to dial A. Step 2. We read the numbers by the pointer of the dial. So from A to D, we'll have 2, 6, 8, and 1. For the final step, unlike the electric meter where we record it as it is, we record the number from right to left. Therefore, from this illustration, the reading is 1,862 cubic meters. Next, let's talk about the digital meter. Unlike the analog meter, the digital meter, the water meter shows 7 dials, and to get the exact meter reading, we start from left to right. So let's take a look at this example, this picture. The last 3 numbers on the right side of the digital meter, which in this case is 2, 5, and 2, they show the part of the water that is used or that is less than 1 whole unit, just like a fraction or a decimal. So this picture shows that the water consumption is 252 liters. So to convert this into cubic meters, we just divide the 252 liters by 1,000 to get 0.252, since 1 cubic meter is equals to 1,000 liters. So in order to compute the water consumption for a particular period of time, we subtract the previous reading from the present reading, which is very similar to the formula to get the current electric consumption. Great job for finishing your class in learning measurements. You are now one step closer in being a math ninja. Don't forget to like the video down below and hit the subscribe button to be always updated in our next lesson in being a math ninja. Thank you for watching. See ya!